if we want to graph cosecant, we start by considering a different type of graph. We start by considering the graph y is equal to sine of x. You know why we think of graphing y equals sine of x? Cosecant of x is the same as 1 over sine of x. So because of that relationship, we start by graphing sine of x. Fortunately, you are excellent at graphing sine of x. Its amplitude is what? Its period is 2 pi. It's okay if you are tired of writing all the tick marks. We're going to exit that point here in a little bit, where you won't have to write so many tick marks anymore, as Monday that'll kind of be done. And where does sine start? Max, min, or middle? Middle. Head by going up or down? Up. I go through my sequence. This is the graph that I get. So far, we have produced nothing of the graph of cosecant. We've only produced the graph of sine. Terrible graph, terrible person. Just not what would Michael Scott say. All right. The next step is to consider what it means to be a reciprocal. Look at example at this sine graph. Where is sine equal to 0? Where does the sine graph cross over the x-axis? For what values? Pi, 0, 2 pi, so on and so forth. Everybody agreed? Well, 0 over 1 is 0. What is the reciprocal of 0? Yeah, 1 over 0 is undefined. So therefore, the cosecant graph is undefined for values of 0, pi, and 2 pi, and so on and so forth. So the first thing I know about the graph of cosecant is that wherever sine crosses over the x-axis, at that spot, I'm going to have vertical asymptotes. So far, I haven't sketched anything of the graph of cosecant. We're on our way. We're almost there. Let's continue to look at the graph of sine and look at this idea of a reciprocal. What is the value of the sine graph right here? 1. What's the reciprocal of 1? 1. So therefore, cosecant has a dot right there. Now, let's consider the rest of the sine graph. Is sine positive or negative here? Positive. Is it big or small? Small. What is the reciprocal of a small positive number? A large positive number, right? So, again, right here, small positive, reciprocal, large positive. So therefore, the cosecant graph, if it's the reciprocal, it has that shape. It's a smiley face. We move along. How about right here? What is the value of the graph right here? -1. What's the reciprocal of -1? -1. So the graph of cosecant is simply all of these U shapes. They sit on the maximum or the minimum. Sometimes people call them little parabolas. I understand why, but they are not parabolas, as parabolas definitely go on forever in both horizontal directions. These are confined by the asymptotes. So kind of like parabolas, but we'll call them U shapes for lack of a better word. Okay? What do you think? Looks crazy, right? Like you show grandma and grandpa, hey, here's what we did in math today. They see that and they're like, wow, you must be the smartest person on the planet. Like, there's no way Harvard would not take you. And you're like, well, it's really not that difficult. They're like, oh, trust me, I could never do that. But it's really not that bad, is it? It's not. Secant, instead of graphing sine, we graph cosine, and you go through the same process. So you guys can get that. Let's flip over and let's give it a shot. Let's skip this one right here and go to y equals -3 secant of 2x. I start by graphing y is equal to -3 cosine of 2x because I want to see what the reciprocal graph is first. What is the amplitude of this graph? 3. What's the period? Pi. So note that when I make my graph, I'm going to leave space above and below +3 and -3 so I can show those U shapes. So I'm not going to put 3 all the way at the top. I'm going to put it right here. So got 1, 2, 3, 1, 2, 3. Henrik, do we need to switch Alex for John? Scratch that. If John moves, we don't know what happened to Michaela. So Michaela already admitted she was lost. So you okay there? Michaela, I for some reason I desire to give you a nickname. Okay. I'm gonna work on it. Okay, here we go. Where do we start? Which is it? Max, min, middle? It's the minimum. Cosine starts at the max, min. Because it's negative, we start at the minimum. And from there we go which direction? We go up, 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 and away. What do I do next, do you think? If you think about our asymptotes, where? Thank goodness for Zoe, huh, folks? Sounds like Zoe has a nickname. Could you inform me on this nickname? Zobert. Zoe, how do you feel about this? She did not hesitate. She does not like it. Very good. Okay. Then I will refrain from calling you that. Nikki's laughing. All right. All right. Now what? Draw the U shapes on the maxes or the mins over towards the asymptotes. So, somebody asked, do we cross over the asymptotes? No, you just get really close to them and kind of head in that vertical fashion. That's what the asymptotes do. Provide that shape. Really cool looking graph. We're going to have one more problem to do for our notes, and then you'll have the entire hour when you get back from lunch to do your assignment. The assignment is just front and back, and there are just 8 problems. Let's try the hardest problem that we've done thus far. Negative secant of 2x plus pi over 2 plus 2. We have all components ready to go. Vertical shift, horizontal shift, everything. I start by graphing y is equal to negative 4 cosine of 2x plus pi over 2 plus 2. What is the vertical shift? Good. What is the amplitude? If the vertical shift is 2 and the amplitude is 4, what is the maximum value of the graph? 6. What's the minimum value? Negative 2. Very good. So I'm going to go 2, 4, 6, and then negative 2. I'm going to draw my axis right there. The vertical part of my structure is now taken care of. I'm going to now go for the horizontal structure. What is the period? Very good. It's pi. My daughter got some JV time last night, the basketball game. Scored her first JV points last night. Just 2. She only took 1 shot, so. Nope. She was just right inside the 3-point line. So she responded, ball came to her, and she was open. She took the right shot. So she was excited. She spends much more time passing the ball. Miss 100% of shots you don't take. That's it's an interesting statistic. I appreciate the message behind it, but the mathematics is rather poor. So, all right, here we go. Uh, the horizontal shift. The horizontal shift. Is there a horizontal shift? There is. If we set 2x plus pi over 2 equal to 0, we get 2x is equal to pi over 2. We divide, or negative pi over 2. We divide by 2 and we get x is what? Negative pi over 4. So we have a horizontal shift of negative pi over 4, which is how much in terms of the graph? 1 tick mark to the left. Now, here's where we encounter a slight problem that you're going to work through, and some of you have already figured this out, and good for you. But at this point, we're normally drawing a ghost graph, aren't we? Because we got that horizontal shift thing. Let's not do that. Because could you imagine a ghost graph and then like this thing along with it? Like it would be really difficult to read what we're doing, wouldn't it? So now that you've already had the practice of drawing these shifts with these ghost graphs, let's look at how you can avoid doing that. Let's just locate our starting point. This is a cosine graph where we start at the max, min, or middle. Minimum, right? So we're starting at the minimum. And then would I be going up or down from that spot? So everybody agree I'd start here and I go up there? Well, now let's just apply our shift. The shift is back 1 tick mark. So move back 1 tick mark and just start your pattern there. That way you can avoid the ghost graph. Or in this case, I should say 2 ghost graphs. Kind of have this other ghost graph that's a structure that we're going to use. We're almost done at this point. Done a very good job. You're a very attentive class. Your teacher is a wizard with seating arrangements. We don't put vertical asymptotes where it crosses the x-axis. You put it where it crosses its axis of rotation. Because everything is shifted. And after we mark those, we can go ahead and sketch our U-shapes. And part of what I really like about this again is that as I go through this process, As we go into y equals and you graph that, you can see how accurate our graph really is. And even you can see the little ghost graph in the middle there that I decided to draw as well. So it's not as though we're making these rough sketches. I mean, these really are excellent graphs. Good job.